Alright, so third numerical, okay, a wheel of diameter. So this has been given to us. The diameter of the wheel is 2 meters. Okay, shown in the figure 1.28 with an axle at 0 at point O. A force of 2 Newton is applied. Okay, a force of 2 Newton has been applied over here at point B in the direction shown in the figure. Calculate the moment of force 1 at the center. What is the moment of force at the center? And the second is at the point A. Okay, so what has been given to us? First, we'll note it down. What has been given to us? So, given is a diameter. So, diameter is 2 meter. So, radius would be half of diameter. That would be 1 meter. All right. Force is given to us. Force is 2 Newton. Okay, and what we have to calculate? First, we have to calculate torque at the center. That is at point O. Okay. So we know torque is force into distance. Force is 2 Newton and distance is from center. So this would be radius. Okay, this will be R. So radius is half of the diameter. That is, it will be 1 meter. So 2 ones are 2 Newton meter. So torque would be how much? At point O, it would be 2 Newton meter. Now the second part is, what is the torque at point A? What is the torque at point A? Again, the same thing. The torque is force into distance. Force is 2 Newton. Now the distance is from here B to A. That is the diameter. That is 2 meters. So it becomes 4 to 4 4 2 to the 4 Newton meter. Okay. So at the point A, the torque will be 4 Newton meter. Okay. At point O, it would be 2 Newton meter. All right. Okay. Fourth one. Okay. So a diagram. Okay. I have not drawn the diagram. Okay. A diagram. Okay, there is a scale that has been pivoted over here. Okay, at point O. This is A. This distance is 2 meter and this distance is 4 meter. There are two forces that are acting on it. At point B, one force of 3 Newton, and at point A, there is one force of 5 Newton. Okay. This distance 4 meter, this is 2 meter. Alright. So at the diagram in the figure 1.29 shows that two forces, one of 5 Newton, the other one is of 3 Newton, acting at point A and B of a rod pivoted at a point O, such that OA is equal to 2 meter and this is 4 meter. OB is 4 meter. Calculate first the moment of force F1 about 0. So what is the force? So this is F1 and this is F2. So first, what is the moment of force that is generated by this force F1? Okay, over here at point O. So first, we'll write what has been given for this. So given is for the first one, okay, force, we know force is how much? F1 is 5 Newton and the distance is 2 meters. Therefore, torque we have to find out torque is how much. So torque is force into distance. That is nothing but force is how much? 5 Newton into distance is 2 meter. 5 2s are 10 Newton meter. So this is the torque that is generated at point O because of F1, because of force F1. Second one, the moment of force by F2. So what is the moment of force? Now this force is working downwards. Okay, that means it is working in an anti-clockwise direction. So this torque is in anti-clockwise direction. Okay, so torque is generated in an anti-clockwise. Now because of this force at point B, it would be in a clockwise direction. So let's see how much clockwise torque has been generated. So the moment of force by F2 about point O. So again over here the force F2 is given as 3 Newton and the distance is given as 4 meter. Okay. So again we have to find torque. Torque is how much? So torque is nothing but force into distance. So torque will be 3 Newton into 4 meter. That will give us 3 to 12 Newton meter. Okay, so this torque, okay, because of F2 would be 12 Newton meter. Third is the total moment of two forces about point O. Now, one is going in an anti-clockwise direction, the other one, this torque, is going in a clockwise direction. Okay, so which one is greater? So this torque B is greater. So the total moment of force would be sum of both the forces. Okay, that is T1 and T2. Since they are in opposite direction, this will be like T2 or torque 2 or tau 2 minus tau 1. Okay, why we are subtracting? Because they are in an anti-clockwise. They are moving in opposite direction. One is in a clockwise direction and one is in a anti-clockwise direction. So since the clockwise direction is greater, we are taking greater one first. So 12 Newton meter minus 10 Newton meter. This will give us 2 Newton meter, and this will be in a clockwise direction. Okay, because clockwise torque is greater. Okay, this is 12 and 12 is greater than 10. Hence, when we take the difference, it will give us the total moment. So because of this, it is getting unbalanced, and how much torque it will generate? It will generate a torque of 2 newtons. So suppose you have to balance it, so you have to apply some torque, that some force over here that will generate 2 newton torque. So it will get balanced again. Alright, we'll stop over here. Thank you.